Good morning, class. This is your teacher, Daddy Cause. We're going to continue from where we stopped. In our last video, we talked about temporary hardness, and we saw what causes temporary hardness. That's calcium hydrogen triisocarbonate 4 or magnesium hydrogen triisocarbonate 4 in water. And we saw the method to remove temporary hardness. And we actually discussed, why do we call it temporary hardness? Because it can easily be removed by boiling. So now we're talking about permanent hardness. What is permanent hardness? Unlike temporary hardness, you cannot easily remove permanent hardness by boiling. So what then causes permanent hardness? Remember that temporary hardness are caused by the hydrogen triisocarbonate 4 salt of calcium and hydrogen triisocarbonate 4 salt of magnesium. So that's why it is easy for us to heat them and they can decompose. But permanent hardness is not caused by those compounds. The calcium and magnesium ion that causes the permanent hardness, they are not from hydrogen triisocarbonate 4, which can easily decompose. They are from another compound. Let us see. The calcium and magnesium ions are from tetraoxosulfate 6 and chloride ions, and chloride salt rather, which cannot be removed by boiling. So permanent hardness is actually caused by calcium sulfate or magnesium sulfate, and this compound do not decompose when you heat them. That is why it is impossible to remove permanent hardness by boiling. And that's why we call it permanent hardness. You have to make use of chemical or some other method. What are the methods for removal of a permanent hardness? Number 1, we can use washing soda, addition of washing soda. So when you use soap to wash, add in hard water, that scum that is formed is actually a way of removing hardness from the water. That's why your soap will waste, because it will be using your soap to remove the hardness. And until the hardness gets removed, before you can start real washing. So addition of washing soda remove permanent hardness. Addition of caustic soda. Caustic soda is actually sodium hydroxide. This is sodium hydroxide, caustic soda. Washing soda is sodium triisocarbonate 4, Na2CO3, .10 of water. Remember, washing soda is an hygroscopic, it's an efflorescent salt. Efflorescent salt. That is salt that loses water crystallization. Don't forget that. If you have forgotten, go and watch my video on properties of salt. So number 1 method is by using washing soda. Number 2 is by using caustic soda. Number 3 is by the use of ion exchange resin. Ion exchange resin is an instrument that can exchange ion. So you can exchange the calcium ion with another ion that doesn't cause hardness. Finally, by distillation. Actually, these 4 methods that we are using for removing permanent hardness can also be employed in removing both permanent and temporary. Is that okay? So we can say it can be used for removing total hardness. Total hardness is the combination of permanent and temporary hardness. So we can use all these 4 methods that I'm using to remove permanent hardness now. I can use all the 4 methods for removing temporary hardness as well. So, but those 2 methods for temporary hardness cannot work. Only work for temporary hardness. Now let us see how to remove permanent hardness by addition of washing soda. How do we use washing soda to remove permanent hardness? Washing soda is sodium carbonate decahydrate. That's Na2CO3, 10 of water. Sodium carbonate decahydrate, that's washing soda. Now, this washing soda will react with the calcium sulfate. You know, this permanent hardness. CaSO4, MgSO4, anything SO4 is what that causes the SO4 of calcium and magnesium, that one that causes permanent hardness. Why the bicarbonate of calcium and magnesium, this one they cause temporary. So when you are sure that okay, this compound is calcium sulfate too, I cannot remove the hardness by boiling. So how do you remove the hardness? By adding washing soda. So when you add sodium carbonate, this compound, with calcium sulfate, so what will happen is this. Already you understand the chemical reaction that is going on. This particular sodium will replaces this calcium and forms sodium sulfate. So sodium replaces calcium and it forms sodium. So sodium will meet calcium. Is a normal reaction that you already know. This sodium now will pick up the sulfates, right? So you form sodium sulfates, whereas the calcium will also pick up the carbonate. So you have calcium carbonate. Remember that calcium carbonate is an insoluble compound. So that is how we remove temporary hardness, by addition of washing soda. You can be asked in exam to write an equation for the removal of permanent hardness by washing soda. So you give them this. Now, another example, if it's not calcium sulfate, if it's magnesium sulfate, the same thing will happen. This sodium will pick up sulfate and give us sodium sulfate, whereas the magnesium will pick up carbonate and give us magnesium carbonate. So there's a mistake here. Supposed to be magnesium carbonate, supposed to be Mg. So this Mg picks up CO3. So supposed to be MgCO3. Supposed to be MgCO3. MgCO3, not MgSO4. So that's what will happen. That MgCO3 also is an insoluble salt. Make sure that you correct this. It's MgCO3, not MgSO4. So once you form an insoluble compound with calcium, then you have to remove the calcium ion in form of a precipitate. Another method is addition of caustic soda, sodium hydroxide. So you can see the permanent hardness. This permanent hardness, calcium sulfate and MgSO4 are the permanent hardness. This is our washing soda. So in both cases, whenever you react caustic soda with calcium sulfate, you are going to get an insoluble calcium hydroxide. This one, insoluble magnesium hydroxide. So in both cases, you have precipitated the calcium away as an insoluble compound. Another one is by the use of ion exchange resin. What do you mean by ion exchange resin? So this ion exchange resin is just an instrument that exchange one ion for another ion. For example, now, assuming this is the resin, Na2Y, ion exchange resin is just an instrument, a very common instrument. So if you pass that water that contains calcium sulfate, which is permanent hardness, into it, the calcium will be replaced. This calcium ion will be replaced by the sodium in the resin. So you'll be forming sodium sulfate. You'll be forming sodium sulfate. Na2 will come and react with this sulfate. So you form sodium sulfate. Why the calcium ion will pick up anything that this Y is. This Y is just represent a very large group that will form an insoluble salt with calcium. So this sodium now will pick up sulfate, form sodium sulfate, while the calcium will react with the remaining thing that is inside and form an insoluble compound of calcium. So that's a ion exchange. There's an exchange of ion. You exchange calcium of the sulfate with the sodium of the resin. So the remaining product now inside the resin will be an insoluble calcium compound. This is an example of ion exchange resin. You can see the water is entering into the resin. There's already sodium attached into the wall of the resin. So as the calcium is actually entering, or the magnesium, it will be replacing this sodium. So the machine or the resin will be withholding calcium. It will be attracting the calcium while allowing sodium to leave. It's the calcium ion that actually causes the hardness. So when you have allowed the calcium to be glued in a way, to be glued or attracted to the resin, then the sodium can go. So sodium will enter into the water. This is the water. Sodium will enter into the water while calcium will be removed away from the water, or magnesium in whichever case. So you can see what happens here. The calcium replaces some of the sodium while the magnesium also replaces some of the sodium. So that's what will be happening, that all the sodium here will be replaced completely by the calcium and magnesium. So while the water that you pour inside will be soft. So if you pour hard water into resin now, what will come out from it will be a soft water. You can see. So here now, water that is already having calcium before and magnesium is here now having a sodium ion. So this is hard water. This ion exchange resin. Ion exchange resin. Then water coming out from it is soft water. So that is how ion exchange resin works. It works by exchanging the ions of the water, which makes it hard, and replacing it with other ions that doesn't cause hardness. Calcium and magnesium causes hardness. Sodium ion does not cause hardness. There is sodium ion before inside the resin. When you pour water inside and the water is hard, sodium ion will go into the water, while the ions already inside water will be attached to the resin, and then the water will become soft. As you can see here, this is soft water while this is hard water. So that is how ion exchange resin actually works. Finally, before I go to that, I must let you know that ion exchange resin can remove both permanent and temporary hardness. Finally, distillation. You know what is meant by distillation. You boil the water evaporates into steam, and then you collect the steam back as a liquid. That is called distillation. So if I have hard water and I put it inside a particular bucket like this, I have hard water, then I put it inside this bucket, then I heat the water. I heat it. What happens? Vapor will be formed, right? There will be vapor. So if I collect this vapor using a Liebig condenser, remember Liebig condenser? So if the vapor enter through Liebig condenser and turn back to liquid, remember that only the vapor actually enters here. All right. So no ion will enter. So all the ion that is inside this water will be left in this particular beaker, while only the water vapor will enter into the Liebig condenser and condense back to liquid, and I will collect it here as soft water. So I will collect soft water from here, water that doesn't contain any ion at all, where all the ions of the water will be left inside this particular place. So distillation can also remove both temporary and permanent hardness. So what are the advantages of hard water? Hard water is not that bad. Apart from that, if you waste your soap, there are advantages of hard water. For example, hard water tastes better than soft water. Soft water has no iron, so it doesn't have taste. But hard water have taste and has a pleasant taste than hard water. That's number one. Number two, hard water does not dissolve lead pipe. So if you pass hard water through a lead pipe, the lead pipe will not dissolve. It will not cause lead poisoning. But if you pass soft water into lead pipe, the soft water will dissolve the lead. So anybody that drinks from that soft water might have the tendency of getting lead poisoning. But hard water does not do that. Number three, hard water is good for healthy teeth and bones because of the calcium ions that it contains. So it helps function of teeth of animals and the bones of animals. Then there are some animals that lives in water that use hard water to make their shell. So that is the purpose of the advantage of hard water over soft water. Don't forget, it has pleasant taste, doesn't dissolve lead pipe, is good for bones and teeth. The animals can make use of this hard water in making their shells. What are the disadvantages of hard water? You must be able to know the disadvantage of hard water. Hard water wastes soap. We get that. Hard water wastes soap. It wastes your soap, it wastes your money, because your soap, your clothes will not lather if you wash with hard water. Apart from that, hard water causes foring of kettles and boilers. I've told you that it's a disadvantage. If your kettle is covered with furs or your boiler is covered with furs, FUR, it becomes very difficult for the kettle to conduct heat. The heat conductivity will reduce. So it takes time for water to boil in a kettle that contains FUR. Then number three, hard water interfere with the tie and dye process. Those that are offering dye and bleaching among you, you see that it's difficult to use hard water to dye particular clothes. So those are the disadvantages of hard water. So in our next video, we'll talk about water pollution. How does the water around us get polluted? What method? And how can we prevent it? So as we leave the class, remember that we said permanent hardness is caused by the presence of calcium sulfate and magnesium sulfate in water. We also said that it can be removed by distillation, where you evaporate the water and then you condense the steam back, by ion exchange resin, where the sodium ion inside the resin enters into water and the calcium ion that is causing hardness gets glued or attached into the resin. Then we say it can be removed by caustic soda or can be removed by washing soda. Then we also talk about the advantage of hard water, that hard water actually is good for bones and teeth. That water tastes better in the mouth than salt water. That hard water does not dissolve lead pipe, but salt water do. So those are the advantages of hard water over soft water. The advantages rather. So the disadvantage of hard water is that hard water wastes your soap, causes foring of kettles and boilers, and it interferes with the dye and dye process. It doesn't allow you to actually dye materials very well. Take note, there's a difference between disadvantage of hard water and effect of temporary hard water. Temporary hard water causes stalagmite and stalactites. It causes foring of kettles. So, but the foring of kettles there is a disadvantage and also an effect, because when the kettle is being furrowed, it will no longer be able to conduct conduct heat very, very well. That's why it's a disadvantage. But the effect is that there's a foring of kettle. The other effect of temporary hard water, which is stalagmite and stalactite, is never a disadvantage. So don't write it under disadvantage. If they ask you in WAEC or they ask you in your school exam, don't write it under a disadvantage. It's not a disadvantage. It is just an effect of temporary hard water. So that will be the end of our class today. In our next class, we'll talk about water pollution. So if you have any question, you voice note me, and I'm going to answer your question. You know my number already. If you don't know my number is my WhatsApp number is 070 35111673. So that is my WhatsApp number, 07035111673. So if you have any question based on what we have discussed, you can feel free to voice note me. I'll respond to your question as quickly as possible. So God bless you. We'll meet in our next video where we talk about hardness of water.